kids! Miss Kulkarni here. Let's continue with chemical reactions. And in this video, we will talk about combustion reactions. So let's begin. What exactly are combustion reactions? These are the reactions in which compounds are burnt. And these compounds contain carbon and hydrogen. For every substance, when it burns, what does it need? It also needs oxygen. So it may or may not be given to you, but when a reaction is a combustion reaction, you have to make sure you add oxygen gas as one of the reactant. Now, what are the products of combustion reactions? Carbon and hydrogen both burn with oxygen and they form carbon dioxide and water vapor. So, when we say combustion and we say everything is in smoke, that's because of carbon dioxide and water vapor. Are you guys ready to work on a combustion reaction problem? Over here, we need to write down a balanced chemical equation for combustion of propane gas. Just to remind you, propane, prop stands for 3. That means we need to have a compound with 3 carbon atoms, and general formula for alkane is CnH2n plus 2. So propane will have a formula C3 and H will be 2 times 3, which is 6 plus 2, it will be 8. And it's given to us that propane is a gas. Now remember what we said, we have to always add oxygen gas as one of the reactant when it says combustion reaction. And the products of combustion reactions are always CO2, carbon dioxide and water vapor. Both are gases, so let's put the states as gas there. Now when it comes to balance, there is an easy trick for balancing combustion reaction. What we need to do is look at the number of carbon atoms and match those on the product side. So in propane, we have 3 carbon atoms. Match the number of carbon atoms, so it will be 3 CO2. Then look at the number of hydrogen atoms. We have 8 atoms, so on the right side, match those 8 atoms. It will be 4H2O. 4 times 2 will give us 8. Now look at the product side and count the total number of oxygen atoms. So in carbon dioxide, we got 3 times 2, 6 oxygen atoms, and with water, we got 4 times 1, 4 oxygen atoms. When we add those together, we get answer 10. Now this number must match with the number of atoms from reactant side. And we have O2, a diatomic on the reactant side. That means we have to divide that 10 by 2 and get the coefficient 5O2. So 5 times 2, we end up having same number of oxygen atoms and the reaction is perfectly balanced. Alright, let's move on to the next problem. Over here, we have to find out a balanced equation for the burning or combustion of liquid octane. Octane has the word octa, which corresponds to 8. That means octane will be with number of carbon atoms equal to 8. The formula for alkane is Cn and H2n plus 2. So with that, the formula for octane becomes C8H18. And we know it's a liquid form, so let's write down there L for the state. It's a combustion reaction. That means we have to write down oxygen and that will be gas. The reaction of combustion always gives CO2, carbon dioxide and water vapor. So we got all the reactants and products ready. And now the next thing is balancing the reaction. So let's figure out how many carbon atoms we have. We have 8 carbon atoms on the reactant side. Let's balance that. So it becomes 8 CO2. Let's balance hydrogen. With 18, we should have 9 as the coefficient for H2O. Now let's look at the product side and count total number of oxygen atoms. So in carbon dioxide it's 8 times 2, we get 16, and from water we get 9 times 1, 9. Total will be 25. Now 25 atoms should be matching by writing the coefficient for oxygen over here. Since this is a diatomic, we need to divide 25 by 2. And when we do that, it is 12.5. So 12.5 will be the correct coefficient if you want to match the coefficients on both sides. But unfortunately, we cannot have a coefficient like a fraction. So the reaction is balanced in mathematical form, but in order to balance it chemically, what we're going to do? We're going to multiply the entire reaction by 2. So what is the final answer which we get? It will be 2 times C8H18, and then oxygen will be 12.5 times 2, so it will be 25O2. Repeat the same process for the product, so it will be 8 times 2, 16 CO2, and for water it will be 9 times 2, so it will be 18 H2O, and both of these will have gaseous state there. So there you go, we got reaction perfectly balanced. Let's move on to the next problem, and this one is slightly trickier. So we have to write down a balanced equation for burning or combustion of liquid ethanol, and the formula is given for ethanol C2H5OH. Since it is burning or combustion, we have to make sure we write down oxygen as the gas. Ethanol is given to us as liquid, so let's write down the state as liquid. And the products are, as you know, carbon dioxide and water vapor, and both are in gas form. So that's our reaction. Now we need to balance it, and we are going to use the same principle. We are going to look at number of carbon atoms and hydrogen atoms on the reactant side and match those with the products. So how many carbon atoms we have on the reactant side? Those are 2. Let's go ahead and match those on the product side. Now look at the hydrogen. We got hydrogen atoms 5, and also we got 1 from hydroxide. So total number of hydrogen atoms are 6 on the reactant side. So let's go ahead and match that on the product side. That will be 3H2O. 3 times 2 gives you 6. Now let's calculate how many number of oxygen atoms we got on the product side, and that is 2 times 2, we got 4 from carbon dioxide, and from water we got 3 times 1, which is 3, so we got 7 oxygen atoms. Now the source of oxygen from the reactant side is coming from this oxygen molecule and also oxygen from the alcohol. So before we put our coefficient, we need to make sure we take that 1 oxygen into account. So I'm going to subtract that 1 and get the answer 6. 6 atoms are coming from oxygen molecules. That means we need to divide that by 2 and we get the answer 3. So that 3 is the coefficient for oxygen, and there you go. We got a balanced reaction for burning liquid ethanol. Let's work on one final problem of combustion. And what are we burning in this question? It is liquid propanol, and the formula is given. So let's write down C3H7OH, and you know it, the reactant should be oxygen, and that's a gas. Propanol is given to us as liquid, so let's write down that liquid, and the products must be carbon dioxide and water vapor. And now it's about balancing the chemical reaction. So let's balance carbon. We got 3 atoms. So that becomes 3. Hydrogen, we got 7 and 1. Together makes 8. So that will be 4H2O. When we count the number of oxygen atoms, how many we get? We get 3 times 2, 6, and 4 times 1, 4. So we end up having 10 atoms. Now, don't just simply divide by 2, because we need to make sure we take into account 1 atom of oxygen, and then we find out the coefficient for oxygen molecule. So we subtract 1 from 10, we get 9, and then we're going to divide that by 2 to find out the coefficient. So we get that as 4.5. So mathematically it's a balanced reaction, but in order to balance it chemically acceptable form, we multiply the entire thing by 2, and the final answer is, so there you go. So we got a perfectly balanced reaction. So guess what? You guys learned how to write and balance combustion reactions. I hope you guys enjoyed the video, and I will see you in next video. Until then, bye bye.